Hey everybody, today we are starting chapter 11, which is our solid geometry. So the first thing we're going to look at is what is a solid. And solids are basically all of your three-dimensional figures. They're either flat surfaces or curved surfaces, and every surface is called a face. Okay, so like if we look at this rectangular prism down here, it has 6 rectangular faces. Okay, an edge is where two faces meet, so this is where your sides are meeting, and your vertex is where multiple edges are meeting. So right here at this vertex, this edge, and this edge all meet at one point. So your vertex is a point, your edges are segments, and your faces are polygons. All right. So let's take a look. We have 4 different types of main three-dimensional figures. There is one another. It is a sphere. We'll get to that a little later. But the first one we're going to look at is a prism. Okay. A prism has 2 bases. Okay. And your bases in a prism is going to be any shape that's not a rectangle. Okay, so in this case, I have 2 triangles that are parallel to each other. Those are your bases. It doesn't matter which direction it's facing. Those are your bases, okay? So 2 triangles, those are your bases. It can be hexagons, it can be pentagons, it could be anything, okay? And when those bases are circles, okay, then we have a cylinder, all right? A pyramid comes to a point, okay, which is called the vertex of the pyramid. So with pyramids, there's kind of 2 different pieces of information. You have the regular vertices, so where your edges meet. But when you talk about the vertex of the pyramid, you're talking about that top point here. Okay. And when we're looking at pyramids, the base is the shape that's not a triangle unless they're all triangles. Okay. This is a triangular pyramid. All the bases are triangles, so the base is or all the faces, excuse me, are triangles. So you have a triangular base. When that base is a circle, we have a cone. And again, that tip point of the cone is called the vertex of the cone. So let's kind of look at that a little more in depth with some of that vocabulary. Okay, here with this pyramid, I have faces and I have bases. The faces are called lateral faces, okay, because it's not the base. The base is the shape that's not a triangle. So, okay, in a pyramid, the base is not a triangle. So, base is the shape that's not a triangle. Again, unless they're all triangles, okay? If they're all triangles, then your base is a triangle too. Okay, where your lateral faces meet is called a lateral edge. Okay, where the edges of your base are is called a base edge. Okay, now in a pyramid, we also have 2 different heights. Okay, when I look at the height of the pyramid that goes from that top vertex straight down perpendicular to the base. Remember, just like in our last chapter, your height or your altitude is always perpendicular to the base. We're just looking at that in 3 dimensions now. Okay. When we have a pyramid, remember all of our lateral faces, like if we look here, our lateral face is not the base. They're always triangles. Okay. Well, you have a height of that triangle. And that triangle height is called the slant height, which we use a lowercase cursive L to represent slant height. Okay, so pyramids and cones are going to have both a height and a slant height, and it is important you know the difference. The slant height is the height of that lateral faces. Lateral face is a triangle, so it's the height of the triangle. Sorry. So altitude or height, slant height is slanted, it's leaning over, it goes towards the middle. Okay, when we look at pieces and parts of prisms, okay, again, we have our lateral faces, and those lateral faces in a prism are always going to be rectangles. Okay, so all of your lateral faces are rectangles. So when you have shapes that are not rectangles in a prism, okay, those are your bases. So in this case, I have two hexagons. They are parallel to each other. Those hexagons are my bases. All right, the distance between your bases is your altitude or your height. Okay, when I look at this one, again, my lateral faces are always rectangles. The two faces that are not rectangles in this figure are triangles. So those triangles are my bases. The distance between my bases is the height. So basically what's happened is they've taken this triangular prism and they've laid it down. Okay? But between the two bases is still the height of the prism. Okay? So if you want to make a note over here that the lateral faces in a pyramid are triangles. Okay, maybe make that note to help you remember. So if it comes to a point, your lateral faces are triangles. If you have two bases, then your lateral faces are rectangles because they're connecting both of those bases the same way. All right, let's take a look at how we name some of our figures. Okay, so again, a prism has two bases. Pyramids have one, they come to a point. With the exception of a cube, which is basically a regular prism. Okay, so it's 6 square faces. Other than that, everything is named by the shape of the base. So like we wouldn't call a cube a square prism. Okay, so they're just saying a square prism is a cube. But this one, look here, I have a base here that's a triangle, a base here that's a triangle. That's my triangular prism. Here I have a rectangular prism because all of the sides are rectangles. Okay, here my base is a pentagon, so it's a pentagonal prism. Here my base is a hexagon, and so it's a hexagonal prism. Some people say pentagonal and hexagonal, and that's fine too. Okay, when we look at our pyramids, my base here is a triangle, so it's a triangular pyramid. Here I have a rectangular base, so it's a rectangular pyramid. Pentagonal pyramid, hexagonal pyramid. Okay, so again, it's just based on the shape of that base is how you name your figure. So let's take a look here. I want to use this pyramid, okay, and it tells me it's a square pyramid to complete the following statement. So this is just to kind of get us used to what all the pieces and parts are. So if I look here, triangle VTM. So this triangle right here on the side is a lateral face. Okay, segment MP, which is the blue dotted segment right here, is the height of the pyramid or the altitude. Okay, you'll see both used interchangeably. Ooh, altitude helps if I'm not talking while I'm trying to spell. Okay, you'll see either or all the time. All right, square WSTV. So WSTV, this right down here, is your base. Okay, then let's look at these sides. MS, MV, MW, and MT. Okay, so it's all the segments that are attaching this vertex to the four corners of your bases. Those are lateral edges. Okay, MR, so from M, perpendicular to a base edge, okay, that is your slant height. So it is the height of the lateral face. All right, then we have MP, MR, and PR. So we don't have PR drawn in here. So let's take a look at what PR would look like. If we look at PR right here. So what they're asking is, look right here. What do these three segments form? And that answer is a right triangle. My handwriting is not good today. Okay, so these form a right triangle. Now, when your base is a regular shape, in this case a square, it's a regular quadrilateral, okay, that like point P is going to be in the dead center of the square. So that means, like, let's say this length is 10. Well, this length will be 5. So you may need to do Pythagorean when we get to problems where we're actually using this. You may need to use Pythagorean theorem to either find the slant height or the height. And again, we'll get there in the next couple of days. Okay, so let's look at our real first examples. We want to classify each of these figures. And you'll notice on your notes, because it was hard to see, I added in little dotted lines back here so you would know that where kind of those lines are. So we want to classify each figure. So first things first, if we look at A, it comes to a point. That means it is a pyramid. Okay, so since it's a pyramid, now I look at the shape of the base. All right, I don't know if this is a rectangle or a square, so I'm just going to call it a rectangle because there's nothing that says otherwise. So this is a rectangular pyramid. Okay, then I want to name the vertices. Okay, the vertices are basically all of the points. So my vertices are A, B, C, D, and E. Okay, then I want to name all of my edges. So my edges are all of my segments. So if I'm going to start at E, and I'm going to do my lateral edges first. So EA, EB, EC, and ED. So those are all the ones that go from the vertex of the pyramid to the corners of the base. Now we need to do all the edges around the base. Okay, so my edges around the base are AB, BC, CD, and AD. All right, the next thing I want to do is name the base. And it's going to be, almost wrote square, rectangle, ABCD. Okay, so classify the figure, name the vertices, edges, and the bases. Okay, so same thing over here. We're going to start by classifying the figure. Notice that I have 2 bases and their shapes are circles, so this is a cylinder. All right, I want to name the vertices. Do I have any points? And your answer should be no. There are no vertices here. Okay, then we're going to name the edges. I can't spell today. Edges. Okay, are there any straight edges? Are there any segments here? No, so there are no edges. Okay, then, oh my goodness, I look at my bases. Okay, the shape of my base is a circle. So circle P is one base, and circle Q is the other. All right, so again, we're classifying, naming vertices, edges, and bases. Okay, next thing we're going to look at is cross sections. Okay, a cross section is what happens when you take a 3D figure and just slice it. Okay, so what we're basically looking at is I want you to think about, let's think about an orange. Okay, if you're about to eat an orange and you're not peeling it, okay, you just slice it right in half. When you open up the orange and you look at it from the top, and all you're looking at is a 2-dimensional figure. Okay, you're basically ignoring the whole bottom part of the orange. If you look at the orange from the top after you've cut it in half, you see a circle. That is a cross section of an orange. It's a circle. Okay, so that's what we're looking at here. When I look at A, I'm taking this triangular pyramid and I'm cutting off the top. So when I cut the top off and I look at it from the place where I cut it, what I'm going to be looking at is this shape. I can't hardly see that. Hold on. Let me get a better color. Can't really see that either. Okay, we're looking at this shape right here. Okay, and what is that shape? It is a triangle. Okay, same thing here. When I look at this cylinder, if I chop it off, cut it in half, this one you can think about like if you ever eaten cranberry sauce out of a jar, like the cranberry jelly, you cut it in half, what shape are you looking at? So we're looking at this part right here, and you've got to remember that we're looking at this at a 3D angle. Okay, so it's going to be like what you're looking at is a little bit squished. All right, but it is going to be a circle. All right, so the next thing that I want to know is instead of having these planes slicing our figure horizontally, which is what they're doing now, let's take a look at what would happen if I sliced them vertically. So instead of here, I am going to slice my figure straight down the center. So that means I'm going to go from here, and this one can kind of go wherever we want it to go. If I cut it this way from the point straight down to the sides, what shape do we create here? Well, we are still creating a triangle. Okay? If I look at my cylinder, if I cut it right in half, so I'm going to cut it down the center, down the sides, right here. Well, what shape am I creating here? Okay, I'm creating a rectangle. So your cross sections can change depending on which way you're slicing your figure. For example, if you think of like a block of cheese and you're cutting slices of cheese. Okay, if you cut it parallel to the base, you're going to get rectangles when you slice it. Okay, well, think about like if you just kind of cut off a corner diagonally. Well, then you'd be looking at a triangle. Okay, there's all kinds of different shapes that you can get out of a cube. You can get trapezoids, you can get parallelograms, all kinds of different things. You can get rectangles, squares. There's a lot of different cross sections. So, there are some shapes where you can get multiple cross sections. There are other shapes like the orange, which is a sphere, which is just basically a ball, okay, that you're only going to get one cross section. It doesn't matter how you cut a sphere, you're still going to get a circle every time. All right, so cross sections are going to vary greatly from shape to shape. All right, let's look at one more thing here, and let's talk about rotating a figure. Okay, so right here I have a triangle, and I'm going to rotate it around that line. So what I want you to think about, and you can even create this if you're having if you're having difficulty visualizing it, go cut out a right triangle out of a piece of paper, or a like a note card, something that maybe has a little more thickness to it. Okay, if you cut a triangle out and tape it to your pencil, okay, hold your pencil vertically, just like this line is here, and then spin your pencil using the tip. Okay, so what you're going to see is each piece of this is going to rotate around in a circle, because this has to go all the way around and around here and back to where it starts. So what we're looking at is when we continuously rotate that figure, and it's going to become a cone. Okay? So again, anytime you're having difficulty like visualizing something like that, make something. Draw cut a triangle out, tape it to your pencil, spin it around, see what happens. Okay? So that's all we have for this section today. And then I will see you guys in class, and I hope you guys have a wonderful evening.